All right, good morning, class. Can everybody hear me okay?
Yes.
All right, let's get started then. Last time we had exam number 17. Let's see if we can solve number one. Um, this one, I think we can do this by eye here. Um, we're going to factor this guy. So they want us to use the zero factor property. We know we need an x and an x for the x squared. Now to get this 15 and the 8, we need two numbers that multiply to give us 15, but add to give us 8. And that would be a 5 and a 3. So using the zero factor property, either x plus 5 is 0 or x plus 3 is 0. This one says x is minus 5. This one says x is a minus 3. And that's it for number one. Number two here, first thing we need to do is put this into a standard form. We need to subtract this 15 from both sides. All right, since we have this 6 over here, let's use our trick. We need to use our a times c. 6 times 15 be 90, but it's going to be negative here. Negative 90. So we need two numbers that multiply to give us negative 90. Our b here is a minus 1. So our two numbers also need to add to give us a minus 1. So I'm thinking, let's see, a negative 10, a positive 9. They multiply to give us negative 90, but add to give us a negative 1. So now we can rewrite this minus x. Rewrite it as a minus 10x plus 9x. So now out of here we can factor out 2x. Out of here we'll factor out a 3. So we have a 2x and a 3, both multiplied by a 3x plus 5. So now it's factored, we use our zero factor property. Set each factor equal 0. This one says x is negative 3/2. This one says x is negative 5/3. There's our two answers. All right, any questions? All right, let's find us a quiz number 18. All right, let's see here. Hmm. Five here. Number 2. Page 149. Okay, it's 10:35. We'll take 15, so 10:50 we'll review this. All right, class, we are back. Can everybody hear me okay?
Yes, sir.
All right, so let's solve this quiz here. All right, since we have a 4 for an A, let's do our little trick since it's already in standard form. See, 9 times 4 is 36. So we need two numbers, multiply to give us 36, but add to give us 12. We think 6 and 6, right? That ought to work. I'll scoot this over a little bit. So let's rewrite this 12t as 6t plus 6t. So we'll factor out a 2t. That gives us a 2t plus 3. Factor out a 3. This is another 2t plus 3. So we have a 2t plus 3. There's a 2t plus 3. So since these are the same, 2t plus 3 has to equal 0. The t would be a negative 3/2. Multiplicity 2. All right, 2. Because you get the same answer twice. Okay. Any questions about this? All right, let's look at number 2 here. First thing, let's put it into standard form. All right, now we'll try our trick here again. Oops. 6 times 4, yeah, negative 24 here. B is a negative 23. So how about 24 and a negative 1? No, negative 24 and a positive 1. Yeah, that'll work. So we'll rewrite negative 23x as negative 24x plus x. So let's see, we'll factor out a 4x. That gives us an x minus 6. And then this is 1 times an x minus 6. So we have 4x plus 1 times an x minus 6. So either 4x plus 1 is 0, 4x minus 6 is 0. So either x is a negative 1/4 or x is 6. And there we have it. Quiz number 18 done. Any questions? All right. So last time we left off on number 22 here. So Oh, we are now on 23, page 146. I have 4 more of these that we need to work out. And y'all will all be masters of factoring. All right, this one, let's do our A times C. 7 times 6 is 42. B is a negative 23. All right, let's see. How about 21? Maybe a negative 21. And a negative 2. So we have 7x squared minus 21x minus 2x plus 6. Factor out a 7x, that gives us x minus 3. Factor out a negative 2, get another x minus 3. It's getting crowded. We have a 7x and a minus 2, both times an x minus 3. So either 7x minus 2 is 0 or an x minus 3 is 0. So x is 2/7 or x is 3. That's number 23. Let's do the same trick. 6 times 4 is 24. B is 25. So let's do 24 and 1. So we can rewrite this guy. It's 25x is a 24x plus x. Factor out a 6, x gives us an x plus 4. And we have 1 times x plus 4. We have a 6x plus 1 times x plus 4. So either 6x plus 1 is 0 or x plus 4 is 0. So negative 1/6 or negative 4. That's 24. Here's some with fractions. 16 and 9. Let's see, what can we do here? If we're going to use be easier doing the square root method, right? But they told us specifically to use the 0 point. So let's see. Let's get rid of the fractions, right? If we multiply through by 9, this fraction goes away, but this one won't. So what we'll do is multiply through by 9 and a 16, right? Multiplying both sides. So what would we have here? I need my calculator. So over here, we get the 16s would cancel in the top and the bottom. 9 times 9 would be an 81. But then over here, the 9s would cancel. We'd keep the 16. So that's how you get rid of the fractions. So this is the difference of 2 squares. This is 9x squared minus 4 squared. So remember your difference of 2 squares 9x minus 4, 9x plus 4. All right, this gives us our negative 4 squared. This gives us our 9x squared. We got the negative 9 times 4x, and then the positive 9 times 4x. The middle terms cancel out. So either 9x minus 4 is 0, 9x plus 4 is 0. So x is 4/9, or x is negative 4/9. So that's doing the 0 point, right? Or if we'd have done it the easy way, using the square root method, we'd have just thrown the 1/9 over here, square rooted both sides. Or actually, before we do that, we could multiply both sides by 16/9. X squared would be 16/9 squared, square rooted. Square root of 16 is 4. The square root of 9 squared is 9. So x is positive negative 4/9. All right, number 26. All right, if we're going to use the 0 point method, okay, we can get rid of our fractions. We don't have to, but may as well. If we multiply everything by 4, we get that. This is the difference of 2 squares. All right, 4 is 2 squared. So x is either a positive or negative 2. And now we've worked all 26 examples. So page 147. Let's see what they want us to do here. Graph and identify the following characteristics for the function. All right. A is 2, which is positive, so this thing opens upward. The axis of symmetry, negative b over 2a. So negative 8. 2 times 2 is 4, so this is a negative 2. So there's our axis of symmetry. The vertex lies on that axis, so we plug the negative 2 in, we get 2 times negative 2 squared plus 8 times negative 2. So this is 8 minus 16, so negative 8. So there's our vertex. All right, our y-intercept, plug 0 in, we get 0 back. So there's our y-intercept. Using our mirror property, we know that our other point is right here. All right, so we already know our x-intercepts. We just figured them out. The y-intercept being at 0, 0 is also an x-intercept. And again, the mirror image gives us our other x-intercept. Or we could just set this thing equal to 0 and solve, right? If we factored out a 2, we'd have an x squared plus 4x. 0. If we factor out an x, we get an x plus 4. So we can see either x is 0 or x is minus 4, which is exactly what we have here. Domain, all real numbers. The range, well, it goes down to negative 8 and goes up to positive infinity. Any questions? the height h in feet of a small rocket t seconds after it is launched is given by the function h of t. How long is the rocket in the air? Well, let's set the height equal to 0 because when it lands, the height's 0, and then we'll solve for t. So we set the height equal to 0, and now we solve for the time. So we could pull a negative 16t out of here. We would get a t, the 128 divided by 16 is 8. So we get 2 times here, either t is 0 or t is 8, right? Well, if this is our height and this is time, at time 0 and at time 8. All right, so they want to know how long the rocket is in the air. They're looking specifically for 8 seconds, not the 0 seconds. All right, when is it 112 feet high? Well, let's set the height. Equal to 112 feet. And I'll solve for the time. First, we need to put this in the standard form. We can factor out a negative 16, I think, out of here. So give us a t squared minus 8 plus 7. I need a t here. 16 times 7 is 112. All right, so we can divide by negative 16. So we're factoring this here. So we get a t and a t, minus 7 and a minus 1. So t is 1 or 7, which makes sense. Say this is 1, this is 7. This is 112 feet. So at these 2 times, it's at 112 feet. All right, 148, number 29. Use this equation to answer the following. Solve using the quadratic formula. Okay, well, this thing, first let's factor out a 3. Right, so we can divide by 3. So just looking at this now, our A is 1, our B is 3, and our C is 0. So quadratic formula says negative b plus or minus the square root of b squared minus 4ac all over 2a. We get a negative 3/2 plus or minus. This is 0. Square root of 3 squared is 3. See, 3 is 6/2. So negative 3 plus 6 would be 6/2 or 3. Negative 3 minus 6/2 would be a negative 9/2. Or solve using the 0 factor property. If we factored that, we could factor out an x. So x is either 0 or negative 3. So the differences between the two, well, in this particular case, the 0 factor property is a lot quicker. And we could just look at it and write down the answers. All right, spot the error and correct it. Well, they factored the 4 out incorrectly, right? You're going to factor a 4 out. It would look like this, right? 4 times 12 over 4. The 4s would cancel and give you the 12, right? We need to have a 3 here. So yeah, they factored it out of this one, but they didn't factor it out of the others. So. Yeah. Wrong. All right, if you have 4x squared plus 7x minus 2, you're going to factor, actually, let me make this a 3. If you want to factor a 4 out of here, you totally can. Right? Just because none of these numbers are divisible by 4 doesn't mean you can't factor a 4 out. You can always factor anything you want out, like that. You just end up with fractions. All right, there's our homework section. All right, page 153. Concept review. All right, solve this equation 3 different ways using each of our 3 methods for solving quadratic equations. All right, so let's use the quadratic formula here. First, let's factor out a 5. Right? If we did that. So let's look at this. X squared minus 9 equals 0. So no matter which method you use, you want to pull that 5 out first. So quadratic formula, A is 1, B is 0, C is -9. So X equals negative B plus or minus the square root of B squared minus 4AC all over 2A. So we got a lot of zeros. 4 times 9 is 36. This is 6 over 2. Plus minus. 6 over 2. It's positive or -3. Square root method. We add 9 to both sides. Square root both sides. Okay. Or 0 point method. We'd factor that guy. It's the difference of 2 squares. Looking at our factors here, you tell it's either plus or -3. So you have 3 different methods now for solving quadratic equations. Okay, once you put it this way, you should be able to look at that equation by now and just write down the answers. Obviously here the quadratic formula was the long way, right? Quadratic formula is best used with really complicated looking equations. and you have like decimals or fractions, you can always just plug and chug it and get the answers. Skip all the other manipulations. All right, another rocket with a flight path F. Find the height from which the rocket was launched. Well, at time 0, it's at a height 0. So 0 is the height it's launched at. The maximum height of the rocket, well, the maximum height's going to occur here at the vertex. So first we'll find the axis of symmetry. The time at which it was at its maximum height is negative b over 2a. That's a negative 9 over 2 times negative 16, or 9 over 32. Which, since this is a word problem, let's go ahead and find the decimal here. 0.28, I'm assuming seconds. Let's up here assume feet. So that's the height, not the height, that's the time. Maybe I should put a circle around it instead of a box. It's the time at which it's its maximum height. So F here, which gives the height, we'll just plug in 0.28. So we have negative 16 times 0.28 squared plus 9 times a 0.28. Which is, let's see, 0.28 times a 0.28 times 16, negative 1.254. Now 9 times a 0.28, 2.52. So we're looking at 1.27 feet. 1.27, and this was at 0.28. All right, when does the rocket hit the ground? That's when its height is 0. So if we're going to solve this, let's see here. I can pull out a t. So I got a negative 16t. Actually, let me pull out a negative t here. I get a 16t minus 9. All right. So I can multiply everything by a minus 1. And you can get rid of that. So this is the difference of two squares. This is, no, it's not anymore. So, all right, it's factored. We just set both of our factors equal to 0. So either t is 0 or 16t minus 9 is 0. This one says t is 9 over 16, which is 9 divided by 16, 0.056. So the rocket hits the ground not at time 0, that's when it's launched. It hits the ground at 0.56 seconds. We found by setting it equal to 0 and solving for t. Okay, after a rocket is launched, the path of the rocket is given by g of t. When they say path, I'm assuming that's the height. Okay, A, find the y-intercept and describe what it represents. The y-intercept, plug in 0 for x. See, this would give us a 9. So 9. That's where we're starting out. Notice A here is negative, so this thing opens downward. It might be like this, or it could be like this. if this is also our vertex, which I think it is, notice b is 0. So negative b over 2a is also 0. That tells us that this is our vertex. So that means this thing doesn't go up, because then our vertex will be over here. This thing tells us that this is our vertex. So it's just going to go down like that. So b, the vertex, is the same as our y-intercept, right? Again, negative b over 2a is 0 because b is 0. So the vertex, the y-intercept, one and the same thing. All right, that means it's not going up, it's just going down. It's already at its maximum height. All right, the x-intercept, we got to find this guy here. So we set our height function equal to 0 and solve for the time. Let's see. T squared would be 9 over 16 using the square root method. We get t is positive negative 3/4 or 0.75. In this case, we're not concerned with the negative. We only want the positive one, 0.75 seconds. All right, the differences in our answers for problem 2 and 3 above. Let's see, negative 16t. So it is the same function. No. Notice the difference. Negative 16t plus 9 versus a plus a 9t. Up here, b is 9, c is 0. Down here, b is 0 and c is 9. So this little piece of this thing, that is exactly the same as this. Right, the whole thing's just shifted. All right. So this guy here starts at a height of 9 and then drops down. This one is at a height of 0, goes up and then goes back down. So totally different problems here because of this. They look so similar, right? But they're totally different. Number 1, B, which one was it? B is 9, C is 0. For the second one, B is 0 and C is 9. All right, so we have an F and a G. Explain the difference between the two functions. All right, well, the first one, I can just look at it and tell you the answers are positive, negative 9 using the square root method. This one, the answers are positive, negative 9i. Because whenever you move this thing to the other side, when you set it equal to 0, you get a negative 81. So one of them has imaginary solutions. The other one has imaginary solutions. So real versus imaginary solutions. Can you use all 3 quadratic methods to solve g of x? I think so. So for part C, let's do the quadratic formula. A is 1, B is 0, C is 81. So x is negative b plus or minus the square root of b squared minus 4ac. all over 2a. So this would give us, so the square root of 81 is square root of 81 over 2. Square root of 81. No, this is a negative in here. Hold on. Negative 81. Why do I have a 2 down here? Over 2. Oh. Because there's a 4 there. Let me try this again. I got a 4 and an 81. All right, so this minus gives me the I. Square root of 4 is 2, so that cancels out. The square root of 81 is 9. So the square root method, we would move the 81 to the other side, square root. That minus in there gives us the I. The square root of 81 is 9. And then the 0 point, if we're going to factor this, we would rewrite it as the difference of two squares, x squared minus 9i squared. Remember, the I squared gives you a minus, so the two minuses cancel. So you got x minus 9i times an x plus 9i. So x is positive negative 9i. So there's all three methods there. Of course, they all give you the same answer. Page 154. Solve. I guess we can solve it any which way we want. First thing I'm going to do is multiply everything by a 6. So that would give us 6 over 3 is 2. 6 over 6 would cancel, so we just get 35. And now 6 over 2 is 3. Now I'll put it into standard form. All right, now I'll do my a times c is negative 70. B here is negative 3. So two numbers that multiply to give us 70, a negative 70, but add to give us a negative 3. 7 and 10. About a negative 10 and a positive 7. So I'll rewrite this negative 3x as a negative 10x plus a 7x. And now I'll factor 2x out. I got an x minus 5. Factor 7 out. I got an x minus 5. So 2x plus 7 times an x minus 5. Setting these both equal to 0, I either get an x equals negative 7/2 or an x equals 5. Or we could have used the quadratic formula, whichever way works for you better. The quadratic formula, see, a is 2, b is negative 3, and c is negative 35. We would have said x is negative b plus or minus the square root b squared minus 4ac all over 2a, which would be 3/4 plus or minus the square root of 9 plus 35 times 2 times 4, 280. So 289 square rooted is 17. So this gives me 20/4 or negative 14/4. That's the negative 7/2, and this is the 5. So whichever way you want to do it. Number 7, when solving a quadratic equation using the quadratic formula, how many and what kinds of solutions do you get if the discriminant is positive, negative, or 0? Negative b plus or minus the square root of b squared minus 4ac all over 2a. This is our discriminant. So if that thing is positive, we're going to get plus or minus a real number. So we're going to get 2 real solutions. If it's negative, then we have the square root of a negative. Then we get 2 imaginary or complex solutions. It depends. If this over here, b isn't 0, then you have a real plus an imaginary, which would give you a complex number. If it's 0, then you don't have the plus or minus, and then you only have one real solution. Negative b over 2a. So for part A, you're looking at something like that. Part B, you're looking at something like that where it never crosses the axis. And C here, where it comes down and just touches. All right, let's see, it's 11:33. Let's take a 15-minute break and we'll come back. So 11:48, we will resume. All right, class, we are back. And we're still on page 154. Let's look at number 8. If we want to create a quadratic equation with these solutions, we can work backwards using the 0 point method. We do x minus 5 and x minus negative 8. Just do x minus both of these. We have our quadratic equation. We can multiply it out if you want. We have x squared minus 5x plus 8x, and then minus 40, or x squared plus 3x minus 40 equals 0. These are the same thing. Okay. And you could test it. We plugged a 5 in here. 5 squared, 5 times 3 is 15. This is 25 plus 15 minus 40 equals 0. And if you plug the negative 8 in, I'm sure you get 0 again. So when they ask you to do this, just do x minus each of those and multiply them together. All right, create a quadratic equation that has imaginary solutions. How about x squared plus 1 equals 0? All right, if we were to solve this, we'd subtract 1 from both sides. square root. Right here, you have the square root of a negative. So this is the most simple quadratic equation with imaginary solutions. Okay. Or you're trying to figure it out, start here. All right, just start write that down. As imaginary solutions, just write your solutions down first and then square both sides. Right? The negative squared here goes away. The I squared is -1. Then add 1 to both sides. Okie dokie. Let's move on. He's 155. All right, let's see. Down here. Let's put 3 and 4. Okay. All right, how many x-intercepts are shown? So for number 1, there are 2. List all x-intercepts shown. Okay, well, we got -2, 0, and 2, 0. Does the graph cross or bounce off the x-axis at each x-intercept? Well, they cross. All right, number 2, how many x-intercepts are shown? We have 3. We got one at -3, -1, and a +2. They're listed. Does it cross or bounce off? Well, it crosses at each one. In fact, because I know the x-intercepts, -3, -1, and 2, this would be x minus a -3, x minus a -1, and an x minus 2. This is our function, f of x. For number 1, since these are x-intercepts, this would be an x minus 2 times an x plus 2, or x squared minus 4. Let's look at these. Same questions. Let's see. We have 1 intercept here at -4, 0. All right. Does it cross or bounce off? It bounces off right there at x minus 4. So what this thing would be, x minus a -4. All right, because it touches. Okay. We're looking at this. This is our function f of x. It happens twice. This one over here, there are 0 x-intercepts. All right, it doesn't cross or bounce, right? It never touches it. That means it has imaginary solutions. $156. All right, let's solve by factoring. A times C is a -6. B here is a -5. So let's do -6 and a +1. So we can rewrite -5x is a -6x plus x. And you factor out a 2x, that gives us an x minus 3. And we have a 1 times an x minus 3. So we have a 2x plus 1 times an x minus 3. Setting them equal to 0. It says x is -1/2 or x is 3. I work backwards to write a quadratic equation in factored form with the given solutions. All right, so you set each solution, right? Just start off writing them down and then set them both equal to 0. So here we add 2 to both sides. Here we'd subtract 9 from both sides. Okay, so either you have x plus 2 equals 0 or you have an x minus 9 equals 0. All right, which is what I said before. You just do x minus each of your solutions. So this is x plus 2 times an x minus 9. Write a quadratic equation in factored form with the given solutions. All right, so here if we add 3 to both sides, we get this. Over here if we subtract 8 from both sides. So if either one of these are 0, then either you have x plus 3 or x minus 8 equal to 0. Over here, x equals 0 or an x minus 5 or x times an x minus 5. Same thing down here. You get x minus 4 or x minus a -7/10. Over here you get x minus 2 or an x minus 2 or x minus 2 squared. Okay, so either x minus 2/3 is 0 or an x minus a -1/2 is 0. X minus a -4 or x minus 3/5. This one, they might want you to do it differently. They might be like, okay, either x plus 4 is 0 or you get an x minus 3/5 is 0. If you take this and multiply everything by 5, you got that. So if you did it this way, you'd say, oh, x plus 4 times a 5x minus 3. So comparing these have the exact same solutions. They're the same equation, right? It's just if I multiplied everything by a 5 times 0 is still 0. This would give me a 5x and we get rid of that. So it depends. If you want to have fractions in there, it's fine. If you don't want fractions, you end up with this. But they are the same equation, just off by a factor of 5. Okay, polynomial functions and their graphs. All right, how many real roots are shown in the graph? This one has 3. This one over here has 4. What is the minimum possible degree of the polynomial if it has only the real roots shown? Well, this one's 3 and this one's 4. All right, every time this thing turns around, all right, it increases by a degree. So like this would have 2 roots and have an x squared in it. This one would be an x cubed, right? This one would be an x to the 4th. And so that's what they're talking about. The degree is your highest power of x. All right, so for C here, write a possible equation for the function in factored form with minimum degree. So we got roots at 0, 1, and 2. This one would be x minus 0 times an x minus 1 times an x minus 2. That's a possible equation. This one over here, since we have them at 1, 2, 3, and 4, this would be an x minus 1 times an x minus 2 times an x minus 3 times an x minus 4. It's a possible solution, or a possible equation, I should say. Okay, same thing here. So this one has roots at -2 and 0. So this one would be an x minus -2, then an x minus 0, or x times an x plus 2. Over here we have roots at, say, -1/2, so we'll do x minus a -1/2, and then x minus 3. That's a possible one. Or if I multiplied everything by 2, I could have 2x plus 1 times an x minus 3. All right, these are different functions. One's twice as tall as the other one, right? Because I multiplied by a 2 here. So one's basically twice as tall as the other. So either this is like at -2 for this one, or this is -1 for this one. They look exactly the same. That 2 just makes it stretch vertically by a factor of 2. So either one of these will work, because they ask for possible functions. There isn't just one, because there is no scale here. We don't have what is this value here. All right, it could be 100, it could be 1,000,000, it could be 1, it could be 2. So that's why there's an infinite number of possibilities. This one here is just the simplest. Page 158. Determine whether the fraction is 0 or undefined. You cannot divide by 0, right? Remember, dividing by 0, this is positive or negative infinity, right? Think of a slope, right? Your change in y over your change in x. If you have a line that goes straight up and straight down, all right, which way is it going? Is it going straight up, or is it going straight down? It's doing both, right? But when you're divided by 0, you're dividing by, you're you're going to positive or negative infinity. Think about 1 over 0.00001. This is a number really close to 0, but it's positive, right? So this is big, right? But if I make this number down here negative, right? This is still a big number, but it's negative and huge. So if you look at the bottom number and let it get smaller and smaller and closer to 0, this gets closer and closer to infinity. But if you get closer and closer to 0 from the negative side, this thing here goes to negative infinity. All right. 8 goes into 0 exactly 0 times. Okay. You can always have a 0 on top. That's not a problem. Here we have a 0 on the bottom, undefined. Here we have a 0 on top. That's fine. That's a 0. You cannot divide by 0. Side, whether it's linear, quadratic, then find all values of x that make it true. This x is 7. This is linear, right? 1, 2, 3, 4, 5, 6, 7. That's what the graph of that looks like. This is x equals -3. It's linear. 1, 2, 3. That's what it looks like. This one is x is 9 halves. 1, 2, 3, 4 and a half. That's linear. This one, x equals 7/4. Linear. 1, 2, 3, 4, 5, 6, 7. Those are all fourths. Those are all vertical lines. They're all straight. You don't see any x squareds or x cubes. Those are all linear. On here. We got an x squared. This is quadratic, 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 because they all have x squareds. Find the x's that make this true. This is x plus 1 times x plus 1. If we factor it, so x is -1. Over here, let's see, if we do our a times c, that's going to be a -2. Our b here is a -1. So if we did p to be -2 and q to be 1, we can take that minus x and rewrite it as a -2x plus x. So we can factor out a 2x. So this is an x minus 1, and then a 1 times an x minus 1. 2x plus 1 times x minus 1. So 2x plus 1 is 0, or x minus 1 is 0. So x is -1/2, or x is 1. This guy over here, a times c, is a -42. B is 11. Let's see. What do we got here? 42. 6 and 7. No, not 6 and 7. What are our possibilities here? 42 is 2 times 21. That doesn't work. 3 times 14. That'll work. If we do -14 and 3. No, +14 and -3. So if we rewrite this 11x as 14x minus 3x, we factor out a 2x, we get an x plus 7 and a -3. We got a 2x minus 3 times an x plus 7. So this one tells us x is 3/2. This one tells us x is -7. All right, page 159. Okay, graph x equals 2. Boom. All the points on that line have an x equals 2. What's the slope? It goes straight up and straight down. It's undefined. Right? It's both positive and negative infinity. What is the x-intercept? X equals 2. What is the y-intercept? There is none. It never crosses the y-axis. Graph y equals -3. There you go. Every point on that line has a y value of -3. What's the slope? It's 0. This thing isn't going up or down. It's totally flat. All right. What's the x-intercept? There are none. The y-intercept, what do you know? It's at -3. All right, which of these are vertical lines? Looking up here, if you have y equals with no x's, right, that's a horizontal line. If you have x equals a number with no y's, that's a vertical line. So right here, this is a vertical line. This one's horizontal. This one's vertical. This one's horizontal. This one's vertical. This one's horizontal. This is linear. It has both x's and y's. It's going to be at a diagonal. This one here, horizontal, there's only y's, only x's, only x's. This one's going to be like that. Vertical, horizontal, vertical, horizontal, vertical, horizontal, linear, horizontal, vertical, vertical. All right, rational functions. Fill in the table for the function of 1 over x, then sketch the graph. So 1 over 1 is 1, 1 over 0.1 is 10, 1 over 0.01 is 100, 0.001, 1,000. I think you get the drift here. So you're taking 1 and dividing it by smaller and smaller numbers, which gives you a bigger and bigger number. Now 1 divided by 1 is still 1. 1 over 10, 0.01, 1 over 100, 0.001. So going in the opposite direction here. Okay, so now sketch the graph. Let's say this is 1, 10, and so on. This would be 0.01. Basically, let's look at right here. 1, 1. Okay. As we move this way towards 0, our function gets bigger and bigger. So as we go this way, this guy is going to go up towards infinity. Now, as we move to the right, we get x's that are bigger. This thing gets smaller and smaller. It gets smaller and smaller. All right, let's use our graphing software here. Function, insert function. 1 over x. Okay. Snapshot. So what we're looking at in our chart anyways is just the erase my ugly picture here. So in the chart, we're only looking at the quadrant 1. So 1, 1. That's where we started out. So as we plug in x is closer to 0 as we move this way. Dang it. I lost all my zeros here. All right, as we get closer to 0 this way, our function gets bigger and bigger. So that's why this thing goes up to infinity. Now, as x gets bigger and bigger, meaning we're going this way, our function gets smaller and smaller. That's why this thing gets small and small. It gets close and close to 0, but it never reaches it. All right, so rational functions. All right, we got this 1 over x. It's the most simple rational function. Right, just like we did x, and then we did an x squared, and then we looked at ax squared plus bx plus c. All right, now we're looking at rational functions starting with 1 over x. So we already talked about a and b here, and we sketched the graph. All right, so now we're looking at what do you do when you have basically a quadratic over a quadratic? How do we think about this? All right. First, they want to talk about vertical asymptotes. The vertical asymptote is basically a dotted line, right? Where this thing gets closer and closer to it, but never touches it. Okay. So something like this. Notice up here, we have a vertical asymptote at 0, at x equals 0. This thing gets closer and closer and closer, but it never touches it. We have a horizontal asymptote at y equals 0. This thing gets closer and closer and closer, but never touches it. That's what our asymptotes are. All right. So we're going to learn how to figure out where our asymptotes are. Let's look at the domain. All right. The domain, remember, is how far it goes right and left. Okay. Well, if you look at this guy here, actually, let's look at this. So we're looking at the whole function, all 4 quadrants here. Sure, it goes all the way infinitely to the right, and it goes infinitely to the left, right? But notice right here in the middle, if you plug 0 into 1 over x, you get a 1 over 0, which is undefined. So this right in the center, up and down, is a vertical asymptote here. If you try to plug 0 into your function, you don't get a point back. So that's why for this guy, you can plug in any number x except 0. So for this one, the domain would be all real numbers except for 0. The domain is the numbers you can plug in for x where you actually get a number back for y or f of x. So in this case, you can't plug 0 in. So 0 is not in the domain of this function. So for this one, you cannot plug a 6 in here. If you plug a 6 in, you're going to get a 0 on the bottom. Okay. And that tells you that whatever the graph of this thing looks like, you go over here to 1, 2, 3, 4, 5, 6, you're going to have a vertical asymptote there. All right. You cannot plug a 6 in here because you're going to get 0 and it's going to be undefined. So this thing might look like, it might look like this. Okay. It might look like that. It could look like this. But whatever happens, as it gets closer and closer to 6 here, it's going to veer off. Okay. If we looked at this, let's see, 2x squared plus 7. 2x squared plus 7. Two x squared plus 7 divided by x minus 6. Okay, let me, there. Now, dang it. Let me get a snapshot of this. Okay. All right, so you can see that right here at 6, this thing never touches that, right? It gets closer and closer, but it never touches it. It just goes all the way down. All right, so that's your vertical asymptote at x equals 6. X equals 6 is your vertical asymptote. All right. So this one over here, all right, so the domain is all real numbers except for x equals 6. Okay. I guess the way you could rewrite that would be all real numbers excluding 6. Or you could just say this, x can't be 6. Okay, so this guy over here, we need to find out what makes 0 on the bottom. So we need to factor this guy. On the bottom here, let's see if we can do this, eyeball this. We need an x and x, minus 8 and a plus a 2. So here the domain, x is everything except for 8 or negative 2. You can't have an 8 or negative 2. So 1, 2, 3, 4, 5, 6, 7, 8. We're going to have a vertical asymptote there. And we're going to have a vertical asymptote here at negative 2. Okay, so we will look into these more next time. Let's do, get this out of the way. No. Quiz, no, an exam. This is almost. These controls are in my way. Exam number, what are we looking at? 18. Hold on. Yeah, no problem. Yeah, if you gotta go, you gotta go. I get it, especially for work. Okay, so let's find some exam problems here. Hmm. Let's get some from page 150 here. This over. Solve by factoring. Let's do these ugly ones here with all the fractions. All right, there you go, folks. What is today, Monday? All right, I will see y'all on Wednesday.
Thank you. Have a great day.